In today's video, here is a nice problem is coming from the Sweden Mathematical Olympiad edition 1995 regarding arithmetic and number theory. Here is the following statement: for all a, b, and c as a positive integers. So we have a, b, c are relatively primes to each other. So we get these two integers a and c are odd. Okay, so we get this following equation. We have a squared plus b squared equals c squared. So our goal, we are going to prove c plus b is a square of integers, or b plus c as a perfect square. Okay, in fact this is very important and useful problem, because we are going to use here GCD definition, which can help us to solve many kinds of these problems. So let's get started to see what this one looks like. Since we need this term b plus c, we are going to factor out this one in order to make this equation on the form of b plus c. So let's work on this one. So we get a squared here plus b squared equals c squared. So let's take b squared to the right. If I'm going to do that, I get a squared here equals c squared minus b squared. So this one is written on the form of the difference of the squares. So we are going to factor out that. So we get c minus b factor c plus b. So we get the term which we need. Okay, c plus b. Now we get the left hand side of this equation is a perfect square. So we need the right hand side of this equation to be a perfect square as well. So let's set. First of all, I'm going to determine GCD of this. Let's call D as a GCD of these two terms, c plus b and c minus b. Okay. Now our goal, we are going to find GCD. So what's the value of GCD? Okay, so based on the given information that we have a and c are odd, so which means b must be even. Okay, is even. Then since b is even, we get odd minus even is giving us odd. This is odd. Also this one is odd. Okay, since this one is odd, this one is odd, which means D must be odd. Okay, because the product is odd. Because D divides b plus c, and also D divides c minus b, because they have shared D as a greatest common divisor. Okay, which means D can divide the difference and sum of these two terms. So this one is telling us D divides b plus c minus c minus b. If I'm going to calculate this one, I get 2b here. Also, D divides the sum of these two terms, which is b plus c minus b. If I'm sending out b, so I get 2c here. So based on this information, since D is odd, which means D cannot divide 2 if D is superior equal to 3. Okay, so which means since we have D divides 2b and 2c, which means D divides b also divides c. Okay, but the problem, but b and c are relatively primes based on the given information that we have before. So but b not divides c because they are relatively primes, which means GCD of b and c equals 1. But the problem, we get D divides both b and c. Now we have three informations. We have D divides both b and c. Also D is odd. Also b and c are comprime, and also b and c are relatively primes, which means D must be equals 1. Okay, it can GCD equals 1 here. Thus, since left hand side of this equation is a perfect square, this one is telling us right hand side of this equation is a perfect square. In particular, c plus b is a perfect square because GCD equals 1. Okay, now it's guaranteed you have a perfect square for this term because of the GCD. You can have this one equals 1, you can have this one is taking the whole thing equals e square, but it's not necessary to have this one equals 1. You may have this one equals 3 square, we may have this one equals 5 square, we still have GCD equals 1. Okay, the only thing we are going to bend from this system, we are not going to take GCD is super equal to 2, because if we go going to do that, you will have a problem. It's not guaranteed to have a perfect square here, especially if you have equality here. Okay, so I've done with this problem. If you have any question regarding this problem, just put it in the comment section below. If you have any suggestion, you can put it in the comment section below as well. So don't forget to hit the subscribe button and support the channel, and thank you for watching. I will see you next video. Bye.